Hello, and welcome to the presentation of our research paper titled Automated Assessment of Android Exercises Using Cloud-Native Technologies. I am Daniel Bruzual on behalf of Efficode, a Finnish consulting company specializing in cloud and DevOps, and this work was done jointly with Maria Montoya Freire and Mario Di Francesco from Aalto University in Finland. Mobile applications are difficult to test. They have complex user interfaces that depend on touch gestures, interactions with hardware and software of the phone on which they are installed. Depending on the phone model, screen resolution, and version of the operating system, apps can behave very differently. Installing the application binaries on a phone and manually testing the desired functionality is a time-consuming task. In the context of mobile app development courses, assessment of student assignments becomes even more challenging. In general, applications developed by students are manually reviewed by teaching assistants. This requires a significant amount of work and several weeks for students to get feedback. In the industry, companies are facing the same problems. Before releasing a new version of their application, they must verify that it works correctly. They write user interface tests that simulate the same swipes, presses, and actions that a real user would take. These tests run simultaneously on clusters of real devices or also on virtual devices, emulators, running in the cloud. This setup automates a lot of the manual work and reduces the feedback cycle for developers. This led us to think how to apply the industry best practices to automate the grading of Android applications, and how to employ cloud technologies to support large classes and online courses. One of the most relevant work related to this was carried out by Olivato and Edwards. They automated grading in their Android course by employing a library used in the industry for testing Android applications. Their approach does not require running emulators or using real devices. Instead, the library intercepts and mocks calls to the API methods provided by the Android operating system. Although this approach is fast, it does not always produce the same results as running the application in reality. For this reason, we have focused on testing the user interface in an accurate way. Burkhardt and others automated the assessment of computer graphics assignments in an online learning system. The results show a significant reduction in time-consuming tasks and a positive perception of the students thanks to the system and reduced feedback cycles. Research has also been conducted on using cloud-native technologies, such as software containers, for automated grading, albeit in different contexts than user interface testing. For instance, Micus and others applied such an approach for a distributed algorithms course. Our solution was developed for the mobile cloud computing course at Aalto University in Finland, with over 100 students enrolled every year. The content of the course covers full-stack software development involving a mobile frontend as a native app for Android and a backend running in the cloud. Throughout this presentation, we will focus on the mobile app. Through a series of exercises increasing in difficulty, students learn some of the distinctive features of mobile application development, such as handling of user import, calling APIs, image rendering and memory management, and interacting with third-party libraries or other applications installed on the phone. For each exercises, we, the teaching staff, develop user interface tests and can assign varying number of points depending on the realized functionality. One of the best practices of mobile testing is to use predetermined IDs for elements of the user interface and to refer to these elements by ID in the user interface test. This ensures that variations in the design, such as changing the text of a button or position, don't break the test. By employing this strategy, we were able to write tests once and have them work with the unique designs that each one of the 120 students came up with. Students develop the exercise solution individually as home assignments and submit the application binary through an online learning system. Specifically, we use a system called A+, which is an open source learning management system developed at Aalto University. Based on the test results, a grade is calculated. The system provides several forms of feedback to the student, including screenshots and logs, as well as suggestions in case of the most common mistakes. For instance, the example shows a case where the displayed QR code is not completely displayed on the screen. Thus, it cannot be successfully scanned. But let us look at what happens behind the scenes. The student's submission of the mobile application as a binary triggers the creation of a software container running in the cloud. An Android emulator is started inside the container, and the application binary is installed. Containers are easy to scale, so multiple submissions can be handled in parallel without interference. The teaching staff writes unit tests for each exercise, and these tests use the mobile app testing framework called Appium to interact with the device. This framework is widely used in the industry, and it allows interacting with the user interface of the phone. For instance, it is possible to locate elements on the screen and perform input actions or gestures like swiping. The video you're seeing now shows the testing framework in action. The framework will open the student's application, input text into the field, and verify that the images are correctly loaded. After the test execution, the results are saved in the learning platform and the feedback is presented to the students. The student feedback we received was largely positive. Students mentioned that the system supported their learning, that it was a helpful tool, and that it motivated them to try again when they had missed some points. The system allowed them to learn about corner cases, which they had not initially considered. Some students also appreciated the fairness of the system, as the scores did not depend on the character of each individual teaching assistant. Many students also recognized the speed of the feedback as quick, fast, and even instantaneous. To summarize, we built a container-based grader for Android application that scales in the cloud to support large online courses. And we employed state-of-the-art user interface testing techniques to automate grading. There are still some interesting directions for future work. Our grading system currently supports the A+ learning management system, but it could be easily extended and adapted to other software. Moreover, plagiarism and cheating detection deserve more investigation. It is also possible to use real mobile devices available in cloud data centers, the so-called device farms, instead of emulators. This would reduce the execution time of the grader. Finally, our software is open source. Both the grader and the Android exercises are available on GitHub. And for more information, you can also visit the website cloudscape.aalto.fi. Thank you.